So good afternoon, everyone. I'd like to start by saying thanks for having me to get in the team. Very humbled to be invited and represent the business community on the stage. So what I'm going to talk about very quickly today is 3 real-world case studies where we have taken Earth observation, satellite Earth observation data and applied it to everyday applications. So, for EI, our mission statement is to use space data for the betterment of humans and the planet. And what I'll do is show you how these examples connect into that. So we've been around for about 8 years. We set up an office in Cornwall and have a team working from the Tremo Innovation Centre, which we opened last summer. We see huge potential here in Cornwall for our satellite Earth observation business. The examples I'll be showing you today are environmental. That's really the focus and the core of what we do. So we're all about getting space data out to people, out into the community, getting people actually using space data. We use the term democratizing space data to just get it out there more and more. And it's all about having intelligence. We that's the big word today. That's what this whole sort of conference today is built around, intelligence. But we're all about that intelligence being powered by space data. So, final slide on what we do. We have this core capabilities around Earth observation, remote sensing, huge amount of software engineering, machine learning, a lot of artificial intelligence, machine learning, deep learning capability within our company to analyze the satellite images, to pull out that intelligence. And I'll talk and show you through some direct examples of that. So my first case study is talking about mangroves. We've already heard how this is a fantastic example of a sink for carbon. I think someone earlier on had a statistic around this being one of the best or the second best sort of ecosystem in the world. So I wanted to talk about a project that we've delivered in the Middle East looking at mangroves. So this project started by us creating essentially a nationwide ecological baseline map for all of Abu Dhabi in the Middle East. This is a highly detailed piece of work. So it's mapping every habitat, 53 different habitats that are mapped within here. We designed an entire habitat mapping schema and structure in order to build this map. We then delivered this nationwide map in 2014, covering the whole country. We then delivered an update in 2019, 5 years later. So what the government have there is a baseline from 2014. Then 5 years later, they have another picture of the ecosystems, the habitat, so they can see the change over time between the two. And all of this is being powered by satellites, by Earth observation data. So when we zoom in a little bit, you can kind of see the level of detail that we're looking at here. So we're mapping urban environments, showing the spread of urban environments and the interaction with the natural environment. Satellites have also allowed us to go into the shallow water ecosystems as well. So you see the green patches on the left here are actually seagrass, which is something we've already talked about. So part of this inventory is providing just this huge amount of detailed information to the government over there. The really interesting thing about this map is that we provided it into the Environment Agency, but they then set up a sharing agreement so that it actually went to 60 different government organisations. So that's something that we can learn from in this country. It's all about producing something once and then making sure it gets to the right people and then it's shared many times. That's something that I think is really important. So we then took this map and went into a deeper level of detail on one specific habitat, in this case mangroves. And what we're able to do is go back in time and look at core satellite imagery as far back as 1987. So we were able to go back in time, look at satellites from 1987 and understand the extent of mangroves in 1987. We then looked at them again in 2001 and again in 2017, so we could see how this habitat is changing over time. We then drilled down into a really high level of detail and mapped every single individual mangrove plant, so understanding its size, understanding its health, a variety of other indicators. We've already talked about this a lot earlier today, but mangroves, very, very powerful habitat in terms of coastal protection, in terms of carbon absorption, in terms of fish spawning, but a variety of other things as well. We then took all of this information, and which is quite detailed, and put it into something that was easily usable by a wider range of people. We did that by producing what is essentially a traffic light map at the end of it. So it's a map of all of the mangroves saying, these are the mangroves that you need to watch and focus on and conserve more. So this whole idea of taking this very, very complex data, distilling it down in lots of different ways, but coming up with something that's easy to consume by people. So that's my first example. Just moving on to look at how we've applied this in the UK. This is a very quick example of a project that we're working on at the moment, and this is the kind of thing that could be and should be very relevant in Cornwall. It's actually to take this similar approach and apply it in this has been applied in Nottingham in an urban environment. But this has been all about pushing this data into local authorities in the UK as part of their natural capital accounting, part of understanding biodiversity management. So we've just heard a lot about biodiversity management strategy. This is actually seeing that happening. It's seeing satellite data going into that. So moving on to my second case study, which is about looking at heat. So this is about us taking satellite data and providing climate change indicators from satellite data. So I'm going to have to run through this very, very quickly because I don't have very much time, but what you have here is something that's called the urban heat island effect. What this means is that in urban areas, you see this natural phenomenon where you have dense concrete environments which generate a lot more heat than the surrounding environments and or areas where you've got water or vegetation. So you see this natural rise in heat over very dense urban areas. And what we're able to do with satellites, we're using thermal sensors from satellites, is essentially map where those heat islands are, where those hot spots are in urban areas. This example here is a project we worked on a couple of years ago with Bristol City Council, where we looked at where they've got persistent hotspots and persistent issues around these urban heat islands. And you could see the interplay between what they call blue infrastructure, so rivers and parks, green infrastructure, and then the urban environment. So you could see these hotspots. You can see where these are coming out, these urban heat islands are coming out. This information went into Bristol's climate strategy. So this is fed and is still feeding part of their climate strategy and their climate mitigation strategy. So we were, it's a fantastic project to be involved in because we were brought in, Bristol said, what can you do with space data? What can you do with satellite data? And they involved us right from the beginning. We were involved in a range of stakeholder workshops where we were shown how this data actually connects to people, what it actually means. And then this has helped to drive their climate mitigation strategy into the future. We've then taken the similar approach and combined that with population vulnerability data. So the reason I'm putting this example on the screen here is I'm really, really keen to make sure that all of this data is accessible to as many people as possible. And this map here is actually designed for people who are colourblind. So it's called a bivariate map, and the colour scheme is designed for colour blindness. That's the idea of it. I'm not colourblind, so I can't say whether it is or not, but the idea is where you have darker areas, that's where you have more of something. And the bivariate part of this is that we've taken our heat data and we've taken population vulnerability data and put the two things together. So what that means is you can see where you have populations that are already vulnerable that will become increasingly vulnerable as temperatures rise in the future. So this bit of information has again gone into another example of a climate mitigation, climate adaptation strategy report that's had all of this data feeding it. So this is being fed by our satellite space data. What we did, we took the vulnerability data, we took the heat data, we took the flood data, combined all of that together to show where you have people who are vulnerable, who are going to be more vulnerable as climate change increases into the future. So my third and final case study to show an example of how satellites can be applied is looking at air quality data. So air quality is a global issue. It's an issue everywhere in the world. It's a huge health burden. It's in the news all the time. It's increasingly in the news. We hear about it all the time. But there's quite limited information available about air quality. And what we see is that air quality modelling data is actually more comprehensive than monitoring data. What I mean by that is if you've got a monitoring station, it's recording in one particular location. You might have another one over there, but you don't really know what's happening in between those two locations. So what modelling allows you to do is make that comprehensive coverage across an area. But in order to do that, you need very good input information. And you need that data to be right down to a very fine level of detail, to a street level of detail. So where does air pollution come from? So on the left-hand side of here, you've got, this is an example, it changes from place to place. This is an example over London of where air pollution comes from. You've got all these contributions to air pollution on the left, and then the biggest on the right is road transport. That's not the case everywhere, but it gives you a feel for the contribution that road transport makes to air pollution. And how can satellites help with that? Well, what you're seeing on the screen here is zoomed in satellite images. So on the left, you've got a 50 centimetre satellite image. What that means is that every pixel on here is 50 centimetres in size. On the right, you've got 30 centimetre satellite image. What you can begin to make out on here is the carriageway on the road. You can begin to make out the vehicles. And what we've done is develop an algorithm, so a machine learning algorithm, that automatically recognises and counts these vehicles within satellite images. It understands whether the vehicles are small, medium or large. It understands whether they're moving or not, and we can determine the speed of the movement, and all of that's coming from satellites. We then take that data and we feed that into an air quality model with many other things. So there's many other inputs going into this air quality model. And we've created a European-wide air quality model. What the vehicle data allows us to do is then take that right down to a street level. So we can create this very large model over a very large area, but this detailed transport information and road congestion information is allowing us to model that right down to a street level. So all of this is giving us, it's allowing us to sort of show these critical pollution indicators, and really importantly, this information it's enabling strategy and it's enabling planning and mitigation and so on. Small sort of plug along the bottom there for European Space Agency business applications. I know Andy's in the room over there, but this was all funded and supported to us as a small business by European Space Agency business applications. So this is an outcome of one of their projects. And this data here, we've actually produced this for 50 cities in Europe, and our database is continually growing. We're continually producing this for more and more locations. So that's it from me, really. I'm finishing on the slide I started on, just to talk about mention again about democratizing space data, and hopefully I've shown you a few examples of that. So thanks very much.